Benchmarking PHP code is fun and it has always fascinated me, but it's also tricky and there are more ways to do it wrong than you can count on two hands. And if you are benchmarking wrong, then the results are at best useless, at worst harmful. And at the end of this video, you have learned a list of preconditions for good benchmarking in PHP. One tool that has helped me immensely in designing good benchmarks is Hyperfine. And I want to show you how it works, what its benefits are, and what problems you still need to account for. Moin, I am Benjamin, and I have helped thousands of developers with PHP performance over the last 10 years. What is Hyperfine? You can write benchmarking code easily in PHP without additional help using hrtime function or, more commonly seen, the microtime function. After doing this for myself for years, my colleague Volker convinced me to give Hyperfine a try, and it stuck. Why even use a dedicated tool for benchmarking? Volker wrote about Hyperfine in our blog, and we're going through his work and his examples to understand why Hyperfine helps with avoiding a bunch of benchmarking problems that are very common, but also introduces some. You can install Hyperfine easily on a Mac with brew install Hyperfine, and on many other systems as well with a package manager. And if you have it installed, you can prefix any command with Hyperfine, for example in this case for the bench sleep script, which runs usleep for 100 milliseconds. And then you can also run it for multiple commands, for example php bench sleep PHP with a factor of 2, and then again PHP bench sleep with a factor of 3, and then it will run each of them individually and it will compare the performance against each other. This way you can run alternative implementations for your code and then benchmark them against each other and see which one is faster, which is slower, and pick one of the solutions that you want to use. We use it, for example, also for testing the performance of different PHP versions against each other. Let's say if there is there an improvement in a version, and then test the same code against multiple versions of PHP and see how the performance changed. So what problems do exist with benchmarking now? I want to talk about 7 different things that you should account for when benchmarking PHP code. The first problem we should look into is not using a production equivalent environment. And this can happen because we are running the benchmarks using the PHP CLI command. This means that by default, OPcache is not loaded or not enabled for the CLI, and this can drastically change the performance compared to running the same code in a web server. So let's check that then OPcache is enabled, and also ini-get OPcache enable CLI is set. Otherwise, throw new exception, OPcache not loaded. So let's run the code again. We see, oh, okay, OPcache was not loaded. So let's change the INI for the CLI settings. We load OPcache and next run works. What we also should account for is that Xdebug is not loaded. So this is something where I had like several embarrassing moments where I tested, for example, I think PHP 5.6 against PHP 7 or so, and I saw it so much faster PHP 7, and then realized not only, of course, PHP 7 was much faster than PHP 5.6, but I was off by a big factor because on PHP 5.6 I also had Xdebug running, and I didn't have that on PHP 7. So if PHP Xdebug either it's not loaded or throw new exception Xdebug is loaded, and then we run that. And this is something that specifically with benchmarking can happen because it's a system, you run them on a system where you also develop, so it might be the case that Xdebug is actually on. So here it's off on my machine, and that's fine. We could also account for other things that are non-production ready. It depends on your environment, what you think of, what you should account for. The second problem that you can have is writing PHP code that OPcache optimizes away. So let's say we have code here that has a function foo returning 1, and we want to test if adding a function returning this is faster than just iterating the code here. So this is the original code that we want to test, and we are iterating this and dumping at the end. And then we have also the code where we call the foo function, and we compare that against each other. So let's run PHP bench function loop PHP against PHP bench function optimized away.php. And the file name already gives away the problem. What's happening here is that with OPcache, some of the functions are actually inlined and optimized away. So because the foo function is returning a static value, it will actually compile the code down to look exactly like this. And that means that you need to be careful with certain functions, that you don't write them in a way that OPcache optimizes them for your benchmarking scenario. And in production, you're using a different function, you write it a little bit differently, or it's more complex because that's just the way production code is. So that way you would see that the performance is quite different. So what we found out here is that actually the code for the function optimized away ran faster than the code that's just incrementing the number. So if we relied on that benchmark, we would think that functions in PHP code are faster than just incrementing an integer, which is not true. OPcache optimized this away. In this case, we could fool OPcache into thinking this function cannot be inlined by writing some dummy code that it gets confused by. And if we rerun the benchmarks now, then we see the loop is at 100 milliseconds, and then the function call is much slower. The factor is, it's a factor of 2, and this is way more realistic now. The third problem is not accounting for load on the machine, and this happens with developer machines all the time. So my developer machine has Docker running, has Spotify running, has a browser running open with 1000 tabs. Yes, I'm a tab Messi, and it is usually under quite a bit of load. In this example, we see what's happening. Under load, the benchmark can be off because the machine actually doesn't have enough CPU to run a benchmark on a CPU core without getting interrupted. And Hyperfine checks for interruptions, it checks for statistical outliers, and it warns you about this. If there are outliers, if there are problems, it explains to you that you should run it on a quieter system. And this is very helpful because you can now run the benchmarks as long as you have a run that doesn't show a warning of this kind. Maybe you need to stop a few programs for this to happen, but you will know that like the benchmarks here are not statistically valid because there was a big like spike or change. The third problem you can run into when benchmarking, at least with Hyperfine, is that you don't account for the startup time of PHP itself. So let's run a PHP script through Hyperfine that does absolutely nothing. So it's php empty.php, we run it, and we see that running this empty script takes 50 milliseconds. And this means that running any PHP script, like with this PHP, runs 50 milliseconds, needs 50 milliseconds of startup time. And we need to discount that from all the benchmarks that we are running. So maybe you remember our benchmark from the beginning with the sleep. We can run it again, php bench sleep.php with a factor of 1. We just had 100 milliseconds of usleep. And as we can see, the script is actually not running 100 milliseconds. On average, it's running 167 milliseconds. And this is because of the startup time of PHP itself. And you need to discount that to be able to compare the different runs with each other. What we usually do is we make sure that the benchmark script runs at least 500 milliseconds, or better, like around 800 milliseconds, so that the actual startup time is becoming a very small part of this runtime. The next problem that you can have with benchmarking is not repeating the tests. And this is a problem that Hyperfine accounts for automatically. As you remember, when we run Hyperfine, for example, on our function bench function loop.php. So what we do here is 10 million iterations of an increment. Then it will run this 15 times. And Hyperfine looks at the execution length of the first test and then determines how often it should run them to be able to make a statistically good estimate of the performance. And the reason is you should account for this is first to detect outliers on the machine. So with this, we are able to detect that one run took significantly longer, like this one here. And this might potentially mean that the machine is under load and the benchmark is not reliable. But also, you cannot just take one test and then use this number as the truth. That is not statistically good, and you can be way off by not accounting for changes that or variances in this. Maybe you could argue that running 10 million iterations is already repetition, but for me it's really not. The problem is that you want to see that the performance runs the same when you do 10 million repetitions over and over again. And this is how Hyperfine is able to determine that there are outliers, there is load, and statistically it's very important to have multiple runs and then average them. This goes into the sixth problem that you can have with benchmarking, not using statistical methods to compare the performance. And one problem with benchmarking and comparing stuff against each other is that there is a lot of variance in benchmarks. And with statistical tests, you can give a range that is statistically significant for benchmarks that you run. So let's take again the benchmarking loop code that we had before. PHP bench fn optimized away.php. We run both tests against each other, and we can see that Hyperfine shows the range of the results it has, and it also calculates the variance, and it says not that the test ran for 127 milliseconds on average, but it also says that statistically it fluctuates by 36 milliseconds plus minus around this average. And the same is for the second test. It's 229 milliseconds plus minus 18 milliseconds statistically. So you see this sort of range, and then you can compare if both ranges interlap over each other, and if the ranges overlap for both tests, then this means that statistically they might not actually be different that much, because you could see the same performance for both of them. In this case, we can see the ranges don't really overlap, so statistically this is really a different performance between the two scripts. The seventh problem is optimizing what doesn't matter. And this is a problem that happens a lot with micro benchmarking. So if you're micro benchmarking some construct against each other and then you're increasing the iterations to 10 million, 20 million, 50 million, then you have to ask yourself, are you actually running this that often in your actual PHP code? And then if in the actual PHP code you're only running it like 100 times, then maybe even if you can optimize something, then it wouldn't matter for the end for your script itself, because in real production code it would be just a few nanoseconds improvement that isn't really measurable. Let's take, for example, this case where we run the difference between calling a function prefix with a namespace, so we importing it or we calling it with a prefix name, and not doing that. So we're not importing that. And the difference here is that with this, in the case where it's imported, OPcache can run some optimizations and inline the function. And in this case here, it cannot do that. So let's run both against each other. We can see for the unoptimized code, it runs for 500 milliseconds. For the optimized code, it runs for 300 something milliseconds. And the difference is 1.6 times faster. However, when we look at this, we are really calling count and checking this 20 million times. So the question really is this happening 20 million times in our application? If yes, then this is a very good optimization. If count is only called 1000 times, then you won't see a difference at all. So let's go back to a full example from Volker's blog post, where he tests the sprintf changes that compile down to a string concatenation that were added in PHP 8.4 against each other, previous versions, and using bash slashes and not. So the example first checks for xdebug, as we've seen. It checks for send OPcache and that it's enabled. Has 10 million iterations, 2 cases. I can run the script with backslash or without backslash. And the functions are declared here as using a backslash. Then this will trigger the optimization in PHP 8.4. Or without a backslash, it will not trigger the iteration. So we are iterating over, so running 10 million iterations, calling this function with a string and an identifier concatenating this. So what Volker showed is that Hyperfine can be used to parameterize tests in a very interesting way. So it allows you to more easily run benchmarks with a lot of different parameters. I have the command here. So we can use the -l flag to introduce a parameter. In our case, we want to run h.2 against h.4. And then we also introduce a second parameter mode with backslash and without backslash. And then we specify only one command, PHP, and then appending the version number, running the bench script that we see here above, and then the mode. This will create 4 tests run against each other. So PHP 8.2 with backslash runs around 800 milliseconds. PHP 8.4 with backslash runs much faster, 580 milliseconds. And then again, PHP 8.2 without a backslash runs similarly around 800 milliseconds. And then PHP 8.4 without a backslash also runs at around 800 milliseconds. And we see the end result, PHP 8.4 with backslash run 1.3 times faster than 8.2 with a backslash, 1.4 times, 1.48 times faster than without a backslash. So this helps seeing the performance difference. We run the same script and we add some variation and parameters through Hyperfine. This video gave a good overview about 7 different problems that you can have benchmarking PHP code, how we use the Hyperfine tool, different ways of using Hyperfine, and I hope that you really took something away from it for your own benchmarking. If you like this content about PHP performance, you can follow this channel on YouTube or subscribe to our newsletter. The link is also in the description. Thank you very much. Bye.